Well, I'd like to start off by welcoming you and thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I'm the product manager for the Fischer-Technik Education Division over here at Studica. And today I'm going to provide you with an overview of Fischer-Technik's line of pre-assembled industrial simulation and training models. Now, whether you're an educator at the high school level involved in CTE training, if you're a college professor or an industrial trainer who's teaching programming skills required in manufacturing, or maybe you're a company looking for ways to demonstrate your software-based solutions, or even just someone looking for ways to make IoT-related concepts easier to understand to employees or customers, in any of these instances, I believe this presentation is going to offer some important options for you to consider. And we're going to start off by considering the skills gap. Now, if you've attended any of our other Fischer-Technik education webinars that we've done over the years, you've probably heard me discuss the importance of STEM education. And STEM, of course, is an acronym that stands for science, technology, engineering, and mathematics. And at this point, it really should go without saying that STEM education has been perhaps the most discussed topic in the educational field over the last decade. Now, as most of us are aware, the push for developing STEM skills in students is in large part to help best prepare them to take their place in the modern workforce. Not so long ago, when our parents or even our grandparents were entering the workforce, employers in areas such as manufacturing might have been satisfied with hiring workers who could demonstrate good motor skills and a solid work ethic. But as manufacturing has become more and more dependent upon automated processes and robotic control, employers now desperately need individuals who have a background in areas such as mechatronics, industrial electricity, mechanical components, and programming PLCs. And as it ties in directly with the solutions we're going to be looking at in this presentation, I'm going to consider the last skill area I just touched upon, that of being a PLC programmer. Now, first off, for anyone who may not be familiar, let me explain exactly what a PLC is. The term PLC is also an acronym, and in this case, the letters of which stand for Programmable Logic Controller. Essentially, a programmable logic controller, or again, a PLC, is a very specialized computer that's used to control the types of machines and automated processes typically found in an industrial setting. These are going to be things like an automated manufacturing plant. Now, as the world of manufacturing becomes increasingly dependent upon these automated control systems, the need for workers skilled in the programming of such systems grows exponentially. Now, to get a clear idea of just how highly prized these programming skills are, here are some salary figures for PLC programmers as quoted from job search website nuvu.com. Quote, the average PLC programmer salary in the USA is $78,000 per year or $40 per hour. Entry-level positions start at $43,924 per year, while most experienced workers make up to $132,600 per year, end quote. Now, as I initially prepared this webinar, I took a look at the list of current job openings for PLC programmers on nuvu.com, and this was back in February of 2020. Now, at that time, the listing showed 15 positions being advertised with salaries of over $75,000, two of which listed salaries of $195,000 per year. Now, because of this trend, savvy students are increasingly enrolling in PLC training programs at the college and university level. But at the same time as this workforce of tomorrow is going out to get their training, more and more manufacturing companies who face an urgent need right now are enrolling their incumbent workers into private training schools offering programs like this. So how long does it take to learn PLC programming? Well, depending on a student's background and experience, very basic PLC programming skills can be learned in as little as 30 to 40 hours of training. But of course, to become truly proficient, in all 5 of the most widely used PLC programming languages, which you see listed on the screen now, as well as learning how to efficiently and effectively troubleshoot and address errors and equipment breakdowns, of course, more training would be required. Now, once again, while many students can learn PLC programming skills in a college lab setting, there are, of course, other options available. There's, again, high school CTE or career and technical education programs. There are adult continuing ed programs, vocational training, technical training and trade schools, and employer-sponsored incumbent worker training programs. Now, that all being said, The question that still arises for the educator, and this is whether you're in a university or a vocational school setting, is how do you go about teaching programming skills, PLC skills, in a way that makes it engaging and relevant to the student, whatever their background? How do you get away from the dryness of textbooks and video presentations and instead make it hands-on and realistic? But there are other areas of focus beyond programming that also needs solutions for demonstrating and exploring and understanding the different aspects of automation and control systems. Now, it could be, again, a company involved in creating or marketing a new type of software-based solution that's looking for ways to make more tangible processes which might otherwise be perceived as abstract, or to test it out in a more realistic fashion. Maybe it's a manufacturer looking for a way to better visualize the production process for workers or stakeholders as they prepare to build a new factory. Or perhaps it's a company looking for an engaging way to demonstrate their services or solutions in a public setting, such as a trade show. Now, in each of these cases, and of course there's more, there is a need for finding a solution that is engaging and which can effectively mimic and simulate real-world automated systems. And that brings us to the line of fischertechnik industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line consists of a series of pre-assembled small-scale models which are designed to replicate, in both appearance and in function, various automated robotic machines and systems that are commonly used in commercial manufacturing. But before we begin to look at each of these models, let me provide you with a little bit of background on fischertechnik. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, in the fischertechnik system, it was created with more of an engineering mindset. The core building block in the fischertechnik system is designed to enable attachment from all 6 sides, and because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts that are available will also help builders to address very specific design needs. The fischertechnik system itself was created back in the 1960s by German inventor Arthur Fischer, who's also noted for countless innovations used in both the construction and the automotive industries. Mr. Fischer, at the time of his death in 2016, had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides fischertechnik, Mr. Fischer is also known as the inventor of synchronized flash photography, and that was back in 1949. And he's also the creator of the expanding nylon wall plug, which is used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm sure we've all worked with those. His company, the Fischer Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction. They also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik sets, and it's whether those intended for the retail market or for classroom use, has always been on helping to foster an understanding of technology. Many of the products that are offered by fischertechnik for the education sector are subject-specific sets. And what I mean by that is they focus on different STEM-related topic areas, things like mechanics, pneumatics, robotics, or even renewable energy. Now, in many of these sets, students are asked to build a progression of models using the unique fischertechnik building system. And then once they've built these models, they perform various experiments which allow them to explore and understand aspects of that given subject. Now, there are also sets that are designed to enable schools to offer a complete standards-focused curriculum-based program where the focus is on project-based learning. Now, in these project-based programs, students dive deep into engineering and learning all aspects of the design process, which requires them to work in groups and create various devices and automated machines to meet the criteria being put forth in a series of real-world style scenarios, all based upon their own trial and error, experimentation, and research. The line of fischertechnik simulation solutions, which of course are the focus of our presentation today, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models which replicate, again, in appearance and function, various automated robotic machines and systems. Some of the models included in the fischertechnik simulation line will be things like conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and even high-base warehouse storage systems. Now, besides these individual models, which of course focus on specific automated processes, fischertechnik also offers an integrated factory simulation model. This model consists of 4 individual workstations, which are comprised of a vacuum gripper robot, a high-bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, all designed to work together as one self-contained material cycle. But before we begin to look at the models in the simulation line in more detail, let me very briefly outline some of the advantages of using fischertechnik solutions. Now, I do apologize in advance, as a few of these points are things I've already touched upon, but I think in each case, it is worth repeating. First, fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, in both appearance and function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. And because the models are compact and in most cases tabletop sized, they are not only ideal for use in the classroom or in-office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next factor is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each of the models we're going to look at today is available in a 24-volt version designed specifically for use with industry-standard PLCs. Now, it doesn't matter whether you prefer to use Allen Bradley controllers, Siemens controllers, or even if you like controllers from other manufacturers, companies like Honeywell, Mitsubishi, General Electric, it really doesn't matter. Whatever you use, you can control these 24-volt versions with the PLC that you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language from the languages you see listed on the screen. Now, at this point, I will note that with these 24-volt versions, in most cases, unless otherwise specified, no PLC is included, and all programming and programming guidance, as well as any power sources or other hardware, are of course the responsibility of the end user. Of course, this shouldn't be an issue, as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming in a college, university, or lab setting. Now, the next advantage, in addition, for non-industrial users and for those educators who are not versed in or familiar with PLC programming, there is an option. There are several models which are also available in 9-volt variations. Now, these 9-volt variations ship pre-wired to fischertechnik's own proprietary robotic controllers known as the Robotics TXT controller. And in this case, each controller is pre-programmed using fischertechnik's own RoboPro graphic programming software. Now, in the case of the 9-volt models, the only additional component required will be the addition of one or more 120-volt power adapters, and we will specify that with each model as it comes up. Otherwise, in most cases, these 9-volt models should be ready to use right out of the box. Now, if you're involved in demonstrating or exploring IoT, also known as the Internet of Things, now besides the fact that many end users have adopted many of the models in the primary line of fischertechnik simulation and training models for IoT purposes, fischertechnik does now offer a special IoT-focused version of the factory simulation, which is designed specifically for exploring and understanding cloud-based control in what is sometimes referred to as Factory 4.0. In this case, the model is designed to be both controlled and monitored from a special web-based dashboard. And we are, of course, going to discuss this in more detail just a little bit later. Finally, fischertechnik models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options in the marketplace, you've probably noticed that the entry point for many of these products can easily be $20,000 to $30,000 or even much more. Fischer-Technic simulation solutions, on the other hand, are available starting just at a fraction of that price, and they are also, again, compact, realistic, and high-quality learning and demonstration tools. So with that all said, let's now begin looking at the models that are available. And we're going to start off with the vacuum gripper robot. And you're going to see a video here, and what you're going to see is a vacuum gripper robot, which is a 3-axis robotic model with a vacuum gripping device. The model here is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, which is the blue brick component that you see in the video in certain places, and a solenoid valve. The dimensions of the model are approximately 9 by 19 by 15 inches, and it has a weight of just about 7 pounds. The 24-volt version of this model, as well as all of the first 5 24-volt models we're going to be looking at today, each have a relay board for motor polarity reversal and both a multi-pin connector, and that's 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as well as the following 24-volt models we'll be looking at, will require you, the end user, provide both the PLC and the programming. And I also will mention that for this and all of the models we're going to look at today, specs are also detailed in the products listings found on the Studica website, as well as our product brochure, which I will provide information on obtaining at the end of this presentation. So if you'd like to get one of those, you can just email us or contact us with your information. And while this is playing out, I'm going to have a little bit of water here. And there we go. Moving right along, the next in line is the automated high bay warehouse. The model you're going to see here features a transfer station with conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, along with 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each. I will mention that this particular model is a favorite among educators I've spoken with who teach programming, and the reason for this is because it gives you a lot to work with in regards to the movements of the picker mechanism, as well as the precision required to properly store and retrieve each of these workpieces, each step of which, of course, will require very specific coding. Getting back to the model, the dimensions of the model are approximately 19 by 28.5 by 15 inches, and it has a weight of approximately 18 pounds. Once again, this 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, you will need to provide your own PLC and programming, and I will mention that there is a limited edition 9-volt version, which is also available, which at this time, which again is pre-wired to a pre-programmed TXT controller. And in this case, one 120-volt power adapter is required. We do offer those. The next model we're looking at is the multi-processing station with an oven. This model features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, the standard version of this model is a 24-volt version for use with the PLC of your choice, which with once again, a relay board for motor polarity reversal in both that multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And the limited edition 9-volt version in this case is connected to 2 robotics TXT controllers. And because of that, 2 120-volt power adapters would be required for all operations. And there we go. The next model we're looking at is the sorting line with color detection. Stop that there. This simulation features a system for detecting work pieces of different colors and sorts them via conveyor belt into 3 different storage bins. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for this model are approximately 20 by 14 by 12 inches, and it has a weight of just about 10 pounds. Now, as with the models we've looked at already, the standard 24-volt version has a relay board for motor polarity reversal with both a multi-pin connector, again 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you need to provide the PLC and the programming. And in this case, the limited edition 9-volt version comes pre-wired to a pre-programmed TXT controller, and 1 120-volt power adapter is required. We'll just let these sort through. And we're all set there. The next model we're looking at is the factory simulation, which combines the 4 models we've just reviewed. Again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with oven, and the sorting line with color detection, again, combining them all into one self-contained material cycle. The cycle you're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then they are moved to the multi-processing station with oven. After the work piece has been processed by the multi-processing station oven, it is then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot back to the automated high bay warehouse for storage. Now, as we've already discussed the components of each model previously, I'm not going to belabor it by restating them here. What I do want to discuss are the dimensions of this particular model as a whole, as well as any of the factory models we're going to be looking at today, and we'll be looking at more after. Now, as it again combines 4 individual models into one work cycle, it of course has a much larger footprint, in this case approximately 39 by 31 by 16 inches. And this particular model has a weight of between 43 and 46 pounds, depending upon whether we're talking about the 24-volt version or the limited edition 9-volt version. Now, due to these dimensions, please note that this model can only be shipped flat as freight on a pallet. And I also want to point out that as the factory simulation models, any of the factory simulation models tend to be in pretty high demand, please anticipate that we at times can have a turnaround time of up to 2 to 3 weeks prior to any orders for this model leaving our warehouse. Now, this all depends, of course, on where our stock is and what the demand is at that time, but they can get a little bit backed up, so just know that. Now, moving right along. First, this is currently available in the standard 24-volt version and in very limited quantities in a 9-volt version. Now, in the instance of the 9-volt version, it does come wired to 5 robotics TXT controllers, and because of the way the controllers are daisy-chained, it's going to require 3 120-volt power adapters. Now, as always, the 24-volt version will require the end user to provide all PLCs, programming, and any other hardware required. And again, each station of the 24-volt version has a relay board for motor polarity reversal and both the multi-pin connector Again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And we'll get out of the black screen and move right along. And what I want to discuss is that there is a storage option available for those users of either of the two factory simulations that I just talked about here, as well as the factory simulations we're going to see later in the program. And if you need to, whether you want to transport these models safely or just protect them when not in use, this is the perfect solution. The travel case consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the cases are partially lined with soft foam blocks in different heights to help cushion the models, and it also has 3 internal zipper pockets for storing cables and other accessories. The lower portion is lined with hard foam, and the case is designed so that once the top of the travel case is removed, the model itself can remain in the bottom section of the case and be fully functional and fully usable. The case has exterior dimensions of approximately 41 by 33 by 17 inches, and the case alone has a weight of approximately 53 pounds. Now, please note that even when using the travel case, these models will still need to be shipped flat. So even though I show it in the picture as standing on its side, you would always want to use these cases flat, so long ways laying down. On that note, let's move right along to the rest of the models. The next model we're going to look at is a basic conveyor belt. And this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as you may desire. Components on this model include an XS motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. Now, as before, the standard 24-volt variation includes a multi-pin connector, but in this case, it's a 26-pin with 2.54 millimeter grid, as shown here. And for a limited time, we do also offer 9-volt versions pre-wired to the robotics TXT controller, as shown here. And in this case, one 120-volt power adapter is required for operation. The next model is a variation of the conveyor belt, but in this case, it includes a punching machine, which features essentially the same conveyor as we just looked at, except this time with the machining station built in. Components on this model include 2 XS motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions for the model are approximately 15 by 12 by 7.5 inches, and it has a total weight of about 3.5 pounds. Again, it's available in a standard 24-volt variation with a 26-pin connector, 2.54 millimeter grid as shown here. And also for a limited time, we are offering a 9-volt version wired to the robotics TXT controller, which requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station, along with 4 conveyor belt sections. Components on this model include the 4 conveyor belts, as I just mentioned, 8 XS motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it is available in both the standard 24-volt version with a 26-pin connector and a 2.54 millimeter grid, again for use with PLC of your choice, and in a limited release 9-volt version wired to the pre-programmed TXT controller and requiring one 120-volt power adapter for use. Next is a variation of the idea of a pick-and-place robot, in this case the 3D or 3-axis robot. The 3-axis robot has gripping forceps which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 can turn 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 XS motors, 2 encoder motors, and 4 push-button limit switches. Dimensions for the model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. Again, this comes in either a 24-volt version with the 26-pin connector and 2.54 millimeter grid designed for use with the PLC and programming of your choice, or in a 9-volt version, which in this case alone, is not a limited availability, but is a standard model which is available. And again, this comes pre-wired to a pre-programmed robotics TXT controller, and it does require one 120-volt power adapter. Now that concludes our look at the first 9 variations of simulation models. The next simulation models we're going to be looking at focus specifically on the area of IoT and are designed specifically for demonstrating and teaching about cloud-based monitoring and control. These models go by the name of Training Factory Industry 4.0, and these are available in both 24-volt version for use with PLC and in 9-volt variations for classroom and demonstration purposes. Now, these have been designed to help address how the recent changes in industrial production, which are driven by digitization, have created a need for stronger networking and more relevant information on all production levels. With this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a small scale before they're implemented on a larger scale. Now, as the following video showcasing the 24-volt version does provide a nicely narrated overview of all the aspects of how this factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. So just to review a little bit, the following topics can be addressed with the fischertechnik Training Factory Industry 4.0. They include training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models that we previously discussed, and besides just most notably, the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each individual workpiece, each of which has a unique identification number, which enables the position of each workpiece in the cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, that allows the network TXT controllers to communicate with one another. Now, as there are two variations of the model, let's go over what makes them different aside from the voltage requirements. We'll begin by focusing on the 24-volt version and what makes it unique. First off, it is a bit of a hybrid in that while requiring a PLC for operation and control, it does also incorporate one fischertechnik robotics TXT controller. In this case, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, which is also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. This allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. These, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows the speed of the encoder motors to be controlled via PWM, also known as pulse width modulation. They also have push-pull output stages for phototransistors and buttons. Finally, one of the most important new features. Now, unlike any of the previous 24-volt models that we've discussed today, The new 24-volt Training Factory Industry 4.0 also includes access to a sample program. In this case, the program is created in structured text format, ST, and was created based upon a Siemens S7 1500 PLC, and this is available for download on GitHub. Of course, the new Training Factory can also be controlled with other PLC models besides the Siemens and other brands once the end user makes some small adjustments to the sample program. And if one wanted to do so, the source codes needed for this are also available for download on GitHub. Now, as with the first of the 24-volt models we looked at today, each of the workstations of the 24-volt variation of the Training Factory Industry 4.0 model do have the relay board for motor polarity reversal and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, along with PCB terminals with push-in connections for all inputs and outputs. Now, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the fischertechnik website, or if you would like access, again, you can email me at the end of the presentation. We can get you that. In the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Now, unlike all the other 9-volt versions that we did look at earlier, these are programmed not using the RoboPro programming software that fischertechnik makes, but instead using C, C++. Again, all of the programming is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF which accompanies this model, once you've done that, you should be able to get started pretty quickly. Now, the 9-volt version will require the addition of 3 120-volt power adapters. Of course, it should go without saying that any of these IoT models will require that you both have access to the internet as well as a tablet or a device for accessing the cloud-based dashboard. Dimensions for these models are approximately 39 by 31 by 16 inches, and they have a weight of approximately 51 to 53 pounds, depending on which version we're talking about. Now, as with the 2 factory simulation models we discussed previously, we do recommend the optional travel case to help protect your model during transport or storage. And that's the Training Factory Industry 4.0 model, now available in both 24-volt and 9-volt variations. So, of course, this brings up the question of how much do these models cost? So we're going to take a quick review of each option I've discussed along with the pricing. The vacuum gripper robot is available in 24-volt versions only, and that is $1,010 is the list price. The automated high bay warehouse is available in both versions now. The 24-volt version is $1,159 per unit. The 9-volt version with the TXT controllers is $1,319. The multi-processing station with oven is currently available in both versions. The 24-volt version, again, being $1,010. The 9-volt version with the TXT controller is $1,479. The sorting line with color detection in the 24-volt version is $840 per unit. In the 9-volt version with the TXT controller is $1,129. The basic factory simulation in the 24-volt version is $4,369. In the 9-volt version with the TXT controllers is $5,239. The conveyor belt in the 24-volt version, for use with PLC, of course, $252 per unit. The 9-volt version with the TXT controller pre-connected, pre-programmed is $519. The punching machine with the conveyor belt in the 24-volt version, we listed $336. In the 9-volt version with the TXT controller, it lists at $599. The 3D 3-axis robot in the 24-volt version is $909. In the 9-volt version with the TXT controller is $1,219. And the index line with 2 machining stations in the 24-volt version is $909. In the 9-volt version with 2 TXT controllers is $1,399. The Training Factory Industry 4.0, either the 24-volt version, this again comes with the sample program, which is a big add-on, and the 9-volt version, which of course comes pre-wired to the TXT controllers. In either case, you are looking at $8,235. Keep in mind with the 24-volt version, you still need to provide the wiring to and the PLC itself. But that said, there are 2 new Training Factory Industry 4.0 models in the 24-volt variation that are now available. There is one that includes all of the connections to all the wiring, the power supply for the PLC. In this case, you need to add the PLC itself. Of course, again, you get the sample program. And for that version, you are looking at $11,088 per unit. But there are now two variations that are available with the Siemens PLC S7 1500 included. So this includes all of the wiring, it includes the connection board, it includes the power supplies for the PLC. You will just need the power, one lone power supply for a TXT controller on there. But otherwise, what you're basically looking at is in the educational version for schools, universities, labs, etc. You're looking at a cost of $16,715 per unit. In the commercial version, you're looking at a cost of $18,900 per unit. Other items that are available, of course, the 120-volt power adapters, which, as I mentioned, are used with the 9-volt models, and which, yes, you would require one of these for any of the factory 4.0 models that you're using. Those are $12.99 each, and the travel and storage case that we looked at for all factory simulation and training factory industry 4.0 models, you're looking at a cost of $1,399 per unit. So on that note, if you have any questions, this is the time to use those tools that you can find on the Zoom chat bar. You can use the question and answer window. You can use the chat window. If you have anything that you'd like to ask me, you can go ahead and type it in. If you don't want to do that right now, I'm just going to move right along, because if you'd like to take the next step, and it doesn't matter what you'd like to do. If you'd like to request, I should say, a full color brochure along with the current pricing on these units. If you would like to ask any questions directly about anything that I discussed, didn't discuss, something you'd need to know, like to know, if you would like to request a quote, or if you'd like to speak with your dedicated educational representative, if you're from a school in any of the 50 states, we can connect you with the representative who handles your state. Any of these things and more, you can simply call us at Studica US. Our number toll free is 888-561-7521. You can email us at info@studica.com. Easy enough. Any questions, any inquiries, any quote requests, anything you may care to know about either these fischertechnik models or any of the other fischertechnik items we touched on today, you can email us there. You can also email me directly. So anything, again, specifically that I discussed or that you'd like to know about this or any other fischertechnik items, you can contact me, Lance.Zurek, LANCE.ZUREK@Studica.com. So on that note, I'd like to thank you all very much for taking the time to attend today's presentation. We look forward to hearing from you soon. Take care and have a great afternoon.